Right. So good evening, everyone. Actually, so the previous video which I was talking to you was regarding the overall things which you can do after you join a bachelor's degree. So it's not really related to chemical engineering, but any branch of engineering you may join. All this is true, whatever I said. Now, to summarize everything, like one thing that I want to mention to you is that beware of this thing about 100% placement, because no matter what a university tells you, it's very difficult to get 100% placement. So there may be a situation where you may not be placed through the university, right? But don't lose hope. There's always something known as off campus placement. So there is something known as people in the university who will be making sure that industry people come to your university, basically the professors. And off campus placement is when you yourself take the initiative and you find a industry where you want to go and work with. And in case you don't want to go for these kind of private sector jobs and you want to get a government job, then you'll need to prepare for the gate exam. Well, I would suggest you should prepare for the gate exam, because through the gate exam you can also open one of the doors for research, as well as you can go for government jobs. Now, if you want to go to research but you do not want to do your masters in India, you can always apply for a MS degree or a MINch degree. So MS degree is much more research focused degrees. MINch is kind of not entirely research focused, but industry focused master's degree. These are some degrees which are like given in many universities in abroad. So that is also an option which you can do. And another thing is that even if you want to go for industry and you did not get any good college, you did not get any good industry during your bachelor's, you can always go to an IIT for doing your master's, and then the type of jobs which you will get will be much more R&D related jobs. So the job profile will change, and you might you might consider doing that. Okay, so till now, whatever I said was a generalized view, and it's true for any branch. So now let's talk about chemical engineering. Oh, by the way, let me tell you one thing. Now, whenever someone is going to talk about their branch or anything related to what they're doing, people will be very much like excited about explaining their stuff. So don't get swayed by their words and think that whatever they're saying is correct. And like, be careful before trusting someone, okay? So don't get manipulated by me into thinking that whatever I'm saying is right. So chemical engineering is the best branch to be in. It's nothing like that. It's just that I really like chemical engineering and I really enjoy, but you need to do your own research. So it's better to listen to more people and hear their opinions and views, and then only take your decision, because it's it's a very important decision as of now. So I'm going to give you some general idea of what chemical engineering is about. So first of all, this is not chemistry. So don't make the mistake of thinking chemical engineering contains more physics and maths, although it contains various concepts of chemistry, but it is not chemistry. So the only chemistry subjects that you will find in chemical engineering are chemical kinetics. It will play a pretty big role. Then other than chemical kinetics, maybe polymers, then electrochemistry, basically physical chemistry. Yeah. So if I wanted to write these things, basically physical chemistry plays a big part in chemical engineering, but not that big. I mean, let's say 30% or some. because most of the subjects in chemical engineering will be dependent on physics and maths. And when I'm saying that it will be dependent on physics, it's more like mechanics. And maths is obviously there. I mean, no matter what subject you take, maths will always be present. Now, what does a chemical engineer do? So, a chemical engineer is a person who is going to magnify whatever you are making in a lab. So, let's say you are making a chemical in lab. Now, you want to scale up that chemical. So, you basically need to run an industry, right? Now, the process of scaling up means having a few milliliter and you want to produce that same chemical and produce in tons. Okay. So now comes the interesting part. In an industry, the chemicals needs to be transported from position A to position B, right? Now, how will you transport these chemicals from one position to another position? Now, if you think about it carefully, most of the chemicals that you will be seeing, they are in liquid form. And the reason for that is the liquid forms are easier to transport from one position to another position compared to their solid counterparts. And we do that using something which is known as a pipe. Now, many chemical engineers say that the life of a chemical engineer revolves around pipes. It may sound pretty boring at first, but when you start going deeper into this subject, you really understand how much interesting it is. So we are dealing with fluids. So if you're a chemical engineer, you're going to deal with fluids and lots of fluids. So when you're dealing with fluids, you're basically dealing with the forces that acts in a fluid, right? So you're dealing with mechanics of a fluid. You're dealing with what kind of stresses are generated in a fluid. You're dealing with various types of fluid. So one of the most basic type of fluid that you can think of is a Newtonian fluid. But the polymers and stuffs that you see, these are known as viscoelastic fluids. Now there are many fluids which are known as thixotropic fluid, then shear thinning fluid, and the list goes on and on and on. So if you're doing chemical engineering, you're going to deal with a lot of fluid mechanics. You're going to study about how we define this kind of fluids. And when I'm talking about definition, I do not mean just normal definition. I mean mathematically how to define these kinds of fluids. You're going to learn a lot about vectors, tensors, and tensor algebra and stuff. So you will also be learning about Einstein notation for the ease of doing your maths. So fluid mechanics is one of the subjects which is dealt in chemical engineering. And the reason is that because in an industry, it's really difficult to travel taking solid particles from one position to other position. That is the reason why there are so many pipelines in an industry. Now, in order to make the fluid travel from one point to another, we need to understand the type of fluid that we're dealing with. We need to understand the type of stresses which are generating inside the fluid. We need to understand that when the flow of the fluid will be in a laminar mode or when the flow of the fluid will turn into a chaotic motion, which is known as turbulence. So these are two new terms, laminar and turbulent. And trust me, I mean, my master's thesis was just predicting this onset of turbulence, and it's really interesting. I'm telling you. So basically, I used to make programs like computer program, and then in the program, I used to tell them the parameters that I'm dealing with, and the program would tell me whether the flow will be laminar or the flow will become turbulent. Now you may, okay, so laminar flow means something which is ordered manner. So basically in mathematical sense, laminar flow is something whose velocity profile is known and it is and you will be able to predict it very nicely. But turbulent flow is something where the velocity profile is chaotic. Oh, by the way, velocity profile means how the fluid is flowing. So if you are looking in this diagram, it means that these are the walls and the velocity at the walls are zero. And as you're approaching to the center, the velocity is increasing. But over here, it's chaotic, right? So you may be thinking, why is it important? Now, in an industry, so by now we understand that pipes are needed. We also understand why we are dealing with fluids. Now we need a driving force to make this fluid flow, right? So this driving force is produced by an instrument known as pump, right? Now, so another subject in chemical engineering is pump and how to design a pump. Like there are many various kinds of pumps, and design of pump and stuff is also there. Design of pump. Now, if the flow is going in a laminar mode, that means the pumping cost will be less because you need to insert less pressure. But the moment it becomes turbulent, then some of the fluids will again return back. So the pump will need to have more pumping. So the pump will need to give much more pressure so that the fluid doesn't flow back, right? So basically, your pumping cost increases in the case of turbulent. So when you're running an industry and you want your pumping costs to be less, you would try to keep the fluid flow in a laminar regime, right? But there are other scenarios also. Let's say you want very high mixing of chemicals, right? Let's say you have two different chemicals, chemical A, and there's another chemical which is chemical B, and they're flowing over here. And there is mixing for sure, but you want the mixing to be enhanced. Now, if it is a laminar flow, then the mixing won't be enhanced. So in such scenarios, you would like the flow to be turbulent, right? So see, if by somehow you know how the flow will be, for example, if you understand at which regimes the flow will be turbulent and at which regimes the flow will be laminar. And okay, so what I mean by regime is, let's say, at which flow rate the flow is laminar, or at which flow rate the flow is turbulent, or at which polymer concentration the flow is laminar, or at which polymer concentration the flow is becoming turbulent. If you have those knowledge, then you can actually reduce the cost of pumping in industry, and that's huge. And also you can increase the efficiency of the instruments. For example, if you want enhanced mixing to occur, so if you're making the flow in a turbulent regime, then yes, you can have enhanced mixing. So this is one of the things which a chemical engineer does, like these kind of things. So I talked about fluid, I talked about pipes, I talked about pumps. Now let's say that there is some reaction going on, okay? And due to that reaction, excessive amount of heat is being produced, right? Like, there are various kinds of reactions. Some reactions are known as exothermic reactions. So in exothermic reactions, what happens? Heat comes out from the reactor. Now you want to control that heat, right? So what do you need to do? Now you need to learn about heat transfer. So another subject. This subject deals with how heat is being transferred from pipes or from reactors, or overall how heat is being transferred. This subject's name is heat transfer, and it basically does that. And it may seem pretty simple. To be honest, it is kind of simple to understand. But if you want to apply it in industry, you will need to take care of a lot of factors. So basically, there are instruments whose entire purpose is to take that excessive heat and take it out of the system. Okay, so these kind of instruments are known as heat exchangers. So these are basically there to control the amount of heat which is coming out of some reactors and stuff. So now we covered another subject. We also covered the subject of heat transfer. So let me keep on writing these things somewhere so that you do not forget. Pumps, heat transfer. Now, where is the reaction occurring? The reaction is occurring in a reactor, right? Now, how to design a reactor? This is also something which chemical engineer does. Design of reactors. There's an entire subject known as chemical reaction engineering. This is also something which chemical engineer does. So if I really want to talk about it, I can talk about it for hours, but I don't want to confuse you guys because you're just out of class. You have just passed class 12. So I'll try to keep it simple. So basically in chemical reaction engineering, we talk about how efficient a reactor can be. What kind of reactors are there? Like what are the ideal cases of reactors that you can imagine? And how to control those reactions, how to enhance the mixing. How come the mixing, many a times you may think that if it's mixing in a, like if it is vigorously mixing, then the extent of reaction will be more, but it may not be more. So all these kinds of things you will be able to understand in this subject. So a chemical engineer also deals with such things about reactors and how to design reactors. No, I should have mentioned this before. Thermodynamics. So no matter what you do, no matter what problem you deal with, the last laugh will be laughed by thermodynamics. So the thing is, thermodynamics will not tell you how fast the thing can occur. Thermodynamics will tell you whether the thing will occur or not. So there may be scenarios where thermodynamics is saying that yes, this thing will occur, but in order for that thing to occur, it is going to take 100 years. Like it's such a slow process. So in those cases, we need uh, some transfer things. So now the things which tells us how anything get transferred from one place to another is known as transport phenomena. So thermodynamics is more like the laws of the things. Thermodynamics will tell you whether this thing will ever occur or not. Transport phenomena is more like it will tell you how much time it might take to occur, what is the rate of occurring these things. So thermodynamics does not deals with the rate, it just tells you whether it will occur or not. And transport phenomena is dealing with the rate. Like for example, heat transfer, fluid mechanics, they all fall under transport phenomena. And also mass transfer. Now, I mean, these are some of the things which, oops, sorry. Okay. Now, these are some of the things which chemical engineer does. Now, let me tell you that responsibilities of a chemical engineer. In order to understand this thing, there is a subject known as process control. Now, you know, whenever you're working in a plant, plant means industry, so there are risk of explosions and death, right? Because of varieties of reason. Let's say there was some, okay, so even before talking about that, let me tell you about, let's say you have a reactor, right? And there is some temperature which needs to be kept constant. If the temperature is increasing even more, then the reaction will also increase, okay? So let's say that the reaction is dependent on the temperature. So as the temperature is increasing, the rate of the reaction is also increasing. And as a matter of fact, the heat generated is also increasing, right? So in such a scenario, an explosion might occur. Okay. Now, as a chemical engineer, what you should do is you should make a jacket of cold water outside, and you should make sure that the water is running and it's keeping the temperature closed, right? So this is one thing which you can do. Another thing is there is something known as the feed stream through which the chemical is being poured inside, and there are valves. So valves are basically instrument through which you can control the opening and closing of pipes. Like I told you, the life of chemical engineer basically revolves around pipes, and you will start to understand the excitement with which I'm talking about. So let's say this is a pipe, and there is this opening over here. Now this opening is controlled by something which is known as a valve. Now if the valve opening is like this, like the pipe is fully open, then the chemicals will flow. Now if you close the valve, then the chemicals will stop flowing. Now let's talk about that scenario where the heat is going on increasing and increasing. So in such scenarios, what you should do, you should definitely close this valve so that the feed cannot, like the chemicals cannot get inside the reactor. And you should completely open this valve so that the coolant or the cooling water can go and regulate the temperature. So these are some, so these kind of quick thinkings are done by chemical engineers. And there is a subject which deals with all kind of things like this is known as process safety, and these valves and this kind of controlling the parameters, there is a subject which is known as process control. So as a chemical engineer, you also learn about these things. You learn about how you are able to control the valve quickly. Like you understand that for certain kinds of scenarios you need feedback control. To be honest, feedback control is something which you need almost everywhere. In some scenarios you have both feedback and feed forward. I shouldn't say these things because I don't think you will be able to understand these things, but anyway, these are some type of control strategies which people use in chemical engineering. And I'm telling you, this subject is really exciting. Now, let's say you have many datas with you. Oh, there is another very important subject, which is known as mass transfer. So in mass transfer, you're basically dealing with how a component is getting separated from its mixture, right? So you're basically, so in mass transfer, you need the help of thermodynamics also. So over here, you're basically dealing with distillation columns. Not only distillation columns, you also deal with stripping columns. Then you deal with varieties of things like you cannot like membrane separations and stuff. So these are also very much important, this mass transfer subject. So let's see how many subjects we covered. We covered fluid mechanics, we covered mass transfer, we covered heat transfer, we covered thermodynamics, we covered chemical reaction engineering. Then there's a we covered process control, dynamics and control. We covered transport phenomena. Yeah, I mean, these are some of the subjects. And like when you will actually start reading about these subjects and you will start understanding how things are happening, you will understand how much interesting these are. Now, I haven't yet mentioned about the kind of research which is done in chemical engineering. Although I did mention about my research, but that was in a very basic level. Oh, but before I talk about the research aspects, let me give you some idea about some of the jobs which a chemical engineer need to do. Like if you are in an industry, then you need to have a lot of conversation with people who are working in the field, like laborers. So let's say there is a high pressure steam. Basically, if you open the pipe, the steam will come out and it will totally burn you. And there are laborers who are working in the field. So they may not have this technical knowledge about which pipe is for what, and they might end up making a mistake. So as a chemical engineer, it is your duty to talk with them and make them understand that this is what needs to be done and you're not supposed to do the other thing. So you need to develop how to talk with people. Like you need to develop this habit if you are going to work in field or let's say industry. So you need to develop this understanding of another people, and many a times these laborers may get angry, so you need to calm them and you need to like make them understand. So personally, I haven't done anything in industry because I am like linked towards research, and but I have had many friends, and some of my mentors were really great chemical engineers, and they have a lot of field experience. So from them, I have heard these things. Then, as a chemical engineer, you're given something known as permits. Okay, so there are various kinds of permits. Cold permits means those jobs which are not really that dangerous. Hot permits means those jobs which are very much dangerous. So what happens, let's say there is a distillation column. So distillation column is basically a very huge column through which there are mixtures, and the mixtures are getting separated. So you're basically inputting some mixture of, so for example, you're inputting crude oil, and from the crude oil at the various level, you're getting various parts of the crude oil distilled out. Now let's say there is some part inside the distillation column which is malfunctioning, and you need to check it. Okay, so you will have to send someone inside the distillation column, and he or she will have to check it. Now whoever is going to do that job, you are the person responsible for giving them the permit. So if it is a hot permit, you need to make sure that the conditions inside the distillation column is safe, and only then you should give the permit. Because if something happens to the person who went inside to fix the thing, then you might get arrested because you were the one who signed that permit. So this is just one example. So many a times what happens is you have these kinds of displays, right? So monitors which are displaying you values. So many a times some of the sensors might not work correctly. The sensors may get damaged, and you may see that only one value is appearing on the screen. So if you see that with time the value is not deviating and it is fixed, then there may be something wrong with the sensors. So one thing is that you ask some of the laborer to go and check and let you know what the value is. Now, if the laborer is inexperienced, then he may not be able to tell you correctly. He may think that the sensor is working, and he may say, yes, yes, sir, the sensor is working correctly. But it is your duty to go and check it at least once, because you don't want to mess with these kind of things. So chemical plants are really one of the most dangerous plants. And if you're working as a chemical engineer, it is your duty, because based on what you say, the lives of many more people will be dependent. So you need to take these kind of responsibilities if you're working as a chemical engineer. It's not an easy job, but it's a very interesting job. So as a chemical engineer, you also do a lot of management kind of things also. Like for example, you tell them that what will be the sizing of the reactors, or where the columns should be set up, and this kind of things. So okay, so I guess I gave you a good idea regarding what chemical engineer does on field. Now let me give you some idea regarding what chemical engineer do at research, because I will be able to tell you more regarding the research area. So research is like this. So initially there are various kinds of branches which occurs. Like for example, let's say you are a chemical engineer, so you may think in your mind that, okay, I'm going to do research in chemical engineering based areas. Now there is someone from the physics department, he is thinking in his mind that, okay, I'm going to do some research in physics area. There is someone from chemistry department, like this. So everybody has in their minds initially that they're going to do research in their particular area. But when they will actually start doing research and they will go on digging deeper, they will realize that in research this type of distinctions kind of disappear. So like, of course, you're not going to do research in literature, but person who is doing research in pure maths and the type of research which you're doing will coincide with each other. I'll give you my example. Like I was dealing with viscoelastic fluids, and I was trying to find instability of them. And the type of research which I was doing was also done at Cambridge by, I do not remember his name right now, by a professor in maths department. So he was also doing the same research. like the parameters were different, but the research was same. He was also trying to find the stability analysis. He was trying to find when a flow will, oh, why can't I remember his name though? So basically the research was finding the stability analysis. So he was seeing when a flow will change from laminar to turbulent, the exact thing which we can also apply in industry. See, now the thing is, in research we try to attack those problems which are difficult to answer. Like many a times what you can do is you can make a machine learning model based on input data and output data, and based on that you can make a model. But machine learning model is also not very much trivial, to be honest, because when you're making a machine learning model, you need to make sure that you have sufficient amount of data. And not only that, there are many garbage data is also present, because like I told you, sensors. So sensors may not work accurately at all point of time. So yeah, so those are one way of dealing with problems, but the other way of dealing with problem is going by first principle, going by physics. And this method is much more related to research. Now there are mainly two types of research. One is theoretical research, another is experimental research. And also there are research which are based on academia. So, and there is research going on which is based on industry. Now, one thing is, if you're doing research which is based on industry, then the chances of your paper getting published is reduced, because industry wouldn't want their techniques to be out. But if you're doing research in academia, then your work is published and you can show the entire world what you have found. And industry, most of the time, they collab with academia. They collaborate with each other and they work. So in past, this collaboration was more, but then after the advent of transport phenomena, this collaboration kind of decreased, because transport phenomena is a highly mathematical subject. But then again, now the collaboration has again begun. So that is really nice. So if you're thinking that you want to do research, but you also want to be connected to industry, so these kind of collaborations goes on in IITs. So yeah, so this option is always there. And okay, so theoretical research basically means research which are based mostly on maths and physics. And experimental research are those research where you actually do things with instruments and stuff. Now, let me be clear. Both of the research are very much time consuming and not so trivial, okay? Because you're trying to find out something new and there will be a lot of challenges. In experimental work, based on my understanding, is that initially you have to set up the entire thing. So the initial setup is very difficult. Initially set up the entire thing and managing everything, like the instruments, what kind of instruments are to be used, what kinds of materials are to be used for the reactions and stuff. And but once you are able to understand those things, then things becomes quite easy. However, in theoretical research, like the initial part is difficult in all the cases, right? Even in theoretical. But if you're somehow able to understand how to do the analysis, like no matter what analysis you're doing, and then based on that analysis you're able to create programs or you're able to run simulations and stuff, then things becomes kind of smoother. So in terms of experiments, like there are experiments where you can work in the renewable sector. For example, designing better solar cells and stuff, or something related to renewable. I mean, the thing which comes to my mind is solar cell, to be honest. Then there is nano related stuffs which you can do. Then there is something related to coatings, right? A chemical engineer is popular for making coatings and stuff. Then there is tissue engineering. So tissue engineering is a branch of chemical engineering where you're basically creating artificial organs. Then there is things where you can make sensors at cheap price. So these are some of the sectors where also there is electrochemistry. There is fluid mechanics. But the thing is, all this becomes really interrelated with each other. So you cannot really differentiate too much on them. And it is kind of difficult to talk about this thing. Also, there are a lot of cancer research going on in chemical engineering. Uh, what else? Research on particles in fluids. I mean, fluids is a pretty common theme. Yeah, I guess. Now, one of the things which I noticed is that in India, at least, this in India, until you reach your bachelor's degree, you do not really have much exposure to research or anything. So that is kind of sad because over here, in US, I've seen that students have a much better idea regarding what is done in research and stuff, even before they start their bachelor's degree. So at least they can decide whether they even want to go to research or not. But in our case, we do not get that opportunity to learn about research. So that's why whenever I talk to my juniors, like out of 30 students, maybe two or three people are excited about research. Most of them want to go for job. Now, it may be because in some scenarios they may really need a job right now, but in most of the scenario it is because they do not really have much idea regarding what is done in research. So what I am thinking is that I will make another video where I'll be talking about what are the various kinds of research that can be done, because that is really my like that is the sector which I can talk about better. But anyway, so I hope this video gives you some idea regarding what chemical engineer does. To be honest, I told you in a very crude manner, but anyway. And the thing is, don't get influenced by me or by anyone. Just think carefully about what you want to do, because this is a very important decision that you have to take for yourself. So before taking the final decision, make sure you're watching some other videos also. You're going through some websites and you're trying to understand what the future, whether the things which is being done after bachelor's, whether it interests you or not. And another thing is, initially you may think that you are interested towards something, and after doing something else you realize that your interest has changed. For example, when I was initially doing chemical engineering, I wanted to work in the area of tissue engineering, so making artificial organs and stuff. But then after I went to IIT, my thought process started changing. I mean, when I said that my interest changed, what I really mean to say is that I got way more exposure than I expected. Then I fell in love with fluid mechanics. And then I started working on stability analysis. And currently I'm in Cornell and I'm working in electrochemistry. So you see how your interest keeps on changing because you're getting exposure to more and more new things. So don't be disheartened if initially you want to work in some area but you couldn't get that area, because who knows, your interest might end up changing, right? So that is all that I'd like to say. And like, think very carefully before taking the decision, but once you take a decision, you stick to it. That is the correct decision, because with time you will realize that you will start enjoying the subject no matter what it is. It may be computer science, it may be chemical, it may be electrical, it may be anything. Okay, then, thank you.